Hi all, something a bit different today. We're going to look at a lithium battery pack that I built using salvaged cells from an electric bus EV battery. I built it about 9 years ago and I found it wasn't lasting and it started making weird cracking noises and a funny smell, so we're going to take that apart and see why it failed. And secondly, a bit of things about net zero and this climate change bullshit, and basically how to protect yourself this winter with some few simple things with not much money. We'll get to that straight away. So basically, as you can see here, we've got a USB powered light. Now, with all this net zero stuff, coal power stations shutting down and things like that, there's been a few electricity shortages and there's been a fair few power cuts recently. Now, I think that's just due to faults in the power grid, but nevertheless, what you need to do to protect yourself is basically by something like this cheap USB lights. So you've got some lighting, some cheap power banks. Just buy a few of them that's got USB-C on so you can charge your phone. Can't have too many of those. Simple thing to protect yourself. And we've got things like this. This is one of the lithium batteries I made, which is like a mega power bank. Just you can see there's a car charger in it. It's got a few outputs on it. Switch that on. You can see that one's flat. It's actually a 9-volt battery because it's actually a 24-volt EV battery, and one of the cells was faulty, so I threw that away. So what I've got is a 12-volt pack and a 9-volt pack. So in this box here, we've got a 9-volt battery with a boost converter, boosted it to 13.1 volts, so you can also charge your phone. This thing's got a capacity of about 20 amp hours. Again, so it's a salvaged EV battery pack. You see the battery voltage there is 10 volts. Nominal voltage is 9 volts, but it's a lithium phosphate battery, 3 cells, so it gives you nominal voltage of 9.9 volts. So yeah, that's one of my bigger power bank. You can charge your iPhone from that 3 or 4 times. And now on to the main subject. Right, now for the main subject. Like I say, the previous battery I've just shown you, and this one was made from a 24-volt battery module from an electric vehicle. One of the cells in the pack was faulty, so I was able to salvage it and make 2 batteries, 12-volt and 9-volt, from one 24-volt EV battery. And this is the other one that I made. That previous one used the BMS where the charging port and discharge port's the same. This one, it's got XOR connector for output and a standard cigarette lighter. That's just unused, and that's a power indicator, battery level indicator, which uses a simple circuit to monitor the battery voltage level, and that will change from green to amber to red depending on the charge level. As soon as the battery is faulty, it gets to about 12 volts nominal voltage and then it just dies. So inside here we've got, so the sun's in the window, it's just, I measured it at 17 amp hours and it's supposed to be 30, but as you can see, you can tell with lithium batteries, if they're faulty, they've got a very strong sweet smell that smells a bit like chemicals and bubblegum mixed together. So what we're going to do is take this battery pack apart and just see what has actually gone wrong with it. Now you can, like I say, first instance of a faulty lithium battery is a smell. Now I've opened this up now and there's a very strong sweet chemical smell that smells a bit like nail varnish and bubblegum mixed together. That's the electrolyte leaking out of the cell. And if you can smell that, it's time to don't recharge the battery, whatever you do, and dispose of it as quickly as you can. Now, I bet in this thing there was just one cell that's failed. So what we're going to do is strip all this plastic off, measure the cell voltages and just see what it was. You see it was making a weird cracking sound as well, which I suspect was this expanding. So I'll take this apart and that's it about. Now the lighting in here is a bit poor because I'm doing this on the kitchen worktop, so you just have to excuse that. But in here we've got some spare fuses. which are 30 amp fuses, your power switch for your battery monitor circuit, and battery pack itself. I'm salvaging action with all the electric vehicles that are becoming more commonplace now. There's going to be a lot of battery packs that go to landfill that are probably perfectly fine. She found that there's only probably a couple of 40 cells in them, and they could actually be reused, a lot of them. I've seen a lot of YouTubers they're using these EV batteries and using them for DIY power walls, etc. Now this thing, I'm just going to try and put this to one side. Now the BMS on this one has got a separate charge and discharge port, so what I'm going to do here is this tape has gone all manky. So I built this 9 years ago, and this battery pack was second hand, so this battery is probably about 15 maybe years old plus. Now electric vehicles were not very common then, so I'm not lithium phosphate cells. I believe in the vehicle was 24 volt packs, although I could be wrong. Right, let's get this wrapping taken off, and then we'll go from there. Right, well that's that unwrapped. Admittedly it doesn't smell as bad now that I've taken it out of the case, but you can see here it's made out of foam and some cardboard, which yeah, I think the BMS is hiding under here somewhere. Yes it is. So it's obviously probably just one cell that's failed, but due to the edge of the battery I wouldn't really be using this. I'm just going to scrap it, but it's interesting to see what's gone wrong. Rip that off. Shite out it there. Then we've got here, we've got another fuse in there, 60 amp fuse. Yeah, there's your BMS. 60 amp fuse, and then I've got a 30 amp external fuse, so let's see what's wrong here then. Yeah, it's standard HX 4S 4F 100 amp BMS, which the reviews on the internet suggest that it can handle nowhere near that, but about like 30. Now, let's take this apart so you can see how it's made. You can see it's made up of 3S 4P configuration. Now I can't see any bulged cells, which is a bit odd. Looks okay to me, does that? So let's check the individual cell voltages. In fact, that doesn't even smell anymore, although I've taken the lid off. So this is your negative. And your first battery. Look how I'm not to short these out. Right, got loaded now. It's charging this phone that this video has been recorded on. Cell voltage at the phone is showing 12.3 volts. Let's check these battery packs again. I think it's trapped in. And let's have a look. .16, 3.19, 3.19, 2.90. So it looks like it's the last cell that's faulty. Right, so I think this BMS has a cut-off voltage of 2.8 volts per cell, so yeah, it's the last cell that's defective in this case. Yeah, 2.9 it's dropping. Come on. nothing. Can't really get a good connection. Yeah, 3.14, so it looks like it is, it's that last cell that's faulty. So, yeah, but there's a very slight smell coming from it. See, EV batteries, that's what makes up EV battery pack from a very old Chinese. These were actually sold as just general battery packs, 24-volt battery packs, but they did actually come from an EV originally. Sold as EV batteries. Each cell's got 10 amp hours, so you got 30 amp hour, 3 cells in parallel, and obviously 4 of them in series. So what we're going to do with this is I might try putting on a balancer cells, so they're all charged individually to the same level, and then recharge it fully and see what happens. There's no sign of any leakage. It might not be scrap yet, but we'll see. But yeah, if I do replace it and I build another battery pack, I will do a video on that. In the meantime, I'll try and find some more interesting stuff to buy on eBay to do videos on. But for now, yeah, thanks for watching.